question 4 says the volume occupied by a sample of gas is 240 milliliters when the pressure is 1.20 atm. What volume at constant temperature, I'm going to go ahead and just remove that for us because it's not going to be necessary for you as part of the question. What volume will the gas occupy when the pressure is decreased to 0.860 atm? So now let's go ahead and label all of our given units. The volume is 240 milliliters. My pressure is 1.20 atm. I'm looking for volume. And I'm looking for volume when the gas is now going to have a smaller pressure, specifically 0.860 atm. So now I need to figure out who's my initial and who's my final. The volume occupied by a sample of gas is 240 milliliters when the pressure is 1.20 atm. I'm looking for the new volume when the pressure is now going to be decreased to. So that means once I decrease the pressure from 1.20 atm to 0.860 atm, I'm looking for that new volume. So because I'm trying to decrease my pressure to a whole new unit, this is now my after. So that means this was my P2. So I started with 240 milliliters, that's my V1, that was hanging out at 1.20 atm. I now want to figure out what is my new volume that I have of this gas when I've reduced the pressure to 0.860 atm. Clearly, using Charles's law is going to be of no value because I don't have any units of temperature, so that's not going to be of any help. I want to make sure that I only focus on using Boyle's law. So if I look at the information that I have for Boyle's law is P1 V1 equals P2 V2. This time around, I'm solving for V2, so that means that I'm going to go ahead and divide by P2 on both sides, and now I cancel that out, and I'm left with V2 equals P1 V1 over P2. And I can go ahead and just plug in all of my variables. I have two pressures, and both pressures have the units of atm, so I know that I can put them straight into my formula and not worry about any conversions. So my P1 is 1.20 atm. My V1 is 240.0 milliliters. I'm going to divide that by my denominator, which in this case is 0.860 atm. And if you notice now, when I need to check my units, I have atm in my numerator, atm in my denominator, and I'm left with just units of milliliter. I'm going to leave you to give me a calculation answer, and then to also give me a sig fig answer. And I'm going to let you determine your sig figs for this problem.